Did you know there are 18 different kinds of math? Hi, hello, shalom. My name is Haley Beckel, and I'm filling in for David and Joseph here to tell you that today's video is focused on jerk theory. Don't know what that is? Well, I don't either. But our resident mathematics expert, Joseph, is gonna walk us through the whole thing. Enjoy!
Well, welcome everybody. Today we're going to talk about math. In the UK, they say maths, like plural. Like in English, math is either singular or plural, but in the UK, you can say maths. I don't know why I mentioned that. But anyway, today we're going to specifically talk about calculus. But did you people know out there that there are at least 18 different types of math? And what we want to do is do a whole series on all of them. So there's arithmetic, algebra, geometry, trigonometry, calculus, topology, logic, mathematical physics, theory of computation, information theory, game theory, statistics, probability, set theory, abstract algebra, complex analysis, graph theory, and you listened in, geometry. That's crazy. 18? There's maybe more? So in the year 2025, if UFOs come and visit Earth, they're going to be like, what? You got 20 different types of maths? You're doing it wrong. You're trying too hard. There's an app for that. Anyway, today we're going to talk about a specific thing in calculus because I was never a math person. Not that I couldn't do it maybe, but no, I couldn't. I tried actually. But I think math is pretty. I love the way it looks. I like to draw just like music, like, a bass and treble clef. There's math. Joseph says he can teach calculus in 20 minutes. I'll give you 20 years and you won't teach me calculus. But anyway, there's a specific thing called the jerk theory. It's when they compute when something hits the ground or when something stops. Anyway, so Joseph, take it away. You're going to teach somebody who, yeah. You know what? The people out there will learn it, though. Go ahead.
Okay, so yeah, we're just going to talk a little bit about calculus. A lot of times you'll hear about the calculus, or you're taking calculus in high school, or you're starting it in college or something, and they give you this huge book, right? It's like thousands of pages long, right? And then they say, it's literally, this is the one I've actually had for 50 years, and I've been reading it for 50 years, and it's falling apart, literally. I think look at, you won't believe this. Look at. There's a punch code card in here.
I had one of those.
That shows you how old this edition is.
Right.
And there's even, in this edition that I learned out of, they're still teaching you how to use the slide rule.
Excellent.
This was before, it was before computers, obviously, but it was even before handheld calculators. So recently, since you can't open this up, and I still use it, you can tell I went through kids with it. There's a lot of stickers and stuff on it. So Sean and Chelsea were on my lap when I had to go back and use this. Obviously, I was using it before they were around because they're not 50. But the point is, you get these huge books, and it's intimidating, and you go, this is calculus. And then they go, and calculus was invented by Isaac Newton and Leibniz, right? Two different guys. And they go, they did all of this? These two guys 300 years ago created this whole book? And no, they didn't. They didn't. So basically, this huge book is just two different things. That's all it is. And if you realize that, you can just sort of go, okay, we're going to learn those two different things, and everything else is technique, right? You got, different ways of doing it and solving it, getting into the details, but it's basically only two different things. And the two different things are really simple, right? The first thing, and what's interesting is that Both of those two things were known before Isaac Newton and Leibniz, right? They were known back with Archimedes, 3,000 years ago, right? So, but what Leibniz and Newton did was go, these two things are the same thing. They saw the connection between the two. And when you see the connection to the two, you can solve one or the other by solving, whatever is easier is basically what happens. So there's two things that they do. One is finding the area of a closed space, like a circle, right? And the Greeks did that. Archimedes did that. And they found it of, the square and the circle, but it was difficult. They were doing it through geometry, right? What calculus does it for any closed surface, and you can do it in a matter of seconds. So what the Greeks took years doing, calculus can do, a junior in high school can do it now. And the other part of calculus is finding the rate of change, right? Like if you're driving your car and you're going the same velocity, or you're not doing anything, you're standing still, right? You're not doing anything. Or then you press on your gas and you start speeding up, right? That's acceleration. That means your velocity is changing over time. You start out with 0 miles an hour, and you go to 10 miles an hour, and you go to 20 miles an hour. So you're accelerating, right? And then as you're accelerating, your acceleration can change too, right? You start getting up to 60, or I don't know how you drive, maybe it's 100 miles an hour, but you start approaching 100 miles an hour, you stop accelerating, and then you just go for constant velocity. So the other part of calculus is deriving that rate of change. So if your velocity is constant, your acceleration is 0. If it's changing, you have an acceleration, and your acceleration can change. All right. So the acceleration of acceleration, you can calculate that too. And they use that a lot in crash test dummies, right? Because you have your car and it's got a velocity, and then you can either you're going to hit that, you're going to try to brake, right? So you're decelerating, your acceleration is decreasing, but then when you hit the wall, the acceleration goes to 0 in a small amount of time. And so they have names for that different types of acceleration. And besides velocity and acceleration, the acceleration of the acceleration is called the jerk. And you can see that in a car. Like if you're like driving in a car and someone hits you behind, you get a jerk, right? You're back. So that's acceleration of the acceleration. And then once you hit the wall, it's almost instantaneous acceleration. And then they have names like that for they actually call it, because they're cute, they call it snap, crackle, and pop, because that's when you at the end you're popping your spinal cord or something. But because you can't have infinite deceleration, right? So your spinal is collapsing into a very small amount of time. So what Isaac Newton and Newton did, they discovered that these two things are inverses of each other. That to find the area under the curve, you just have to find out how that curve is changing over time. And to find the acceleration, you can do it in terms of the area under the curve. So the two are, it's like if you go 3 plus 2 is 5, the minus 2 is 3. Subtraction is the inverse of addition, right? If you go 2 times 3 is 6, 6 divided by 3 is 2, division is the inverse of multiplication. If you go 10 to the second, right, is 100. 100 squared is 10. Square roots are the inverse of powers, right? So everybody, mathematicians love inverses. They want to do something and they want to undo it. And it turns out that taking a derivative is the inverse of taking um, the integral. So that was that's what Isaac Newton and Leibniz did. That was their big contribution. And nobody really, and the rest is all details. That's it. Just like you can go on with arithmetic, and put in X's and Y's and make it into algebra and then put it on a graph and make it into analytical geometry. But basically, that's it, right? It just gets more complicated. But when you get to calculus, it's not like more complicated algebra. You actually do make this leap into motion. You're analyzing motion out in common. So to show you how powerful it is, Kepler took 30 years, right, to get by just looking at his little telescope and plotting things, to get the 3 laws of planetary motion, right? That planets are following an ellipse, and the equal time equals area. And he didn't explain why. He said, "This is just it. Just look in your telescope, and this is what you will see if you have enough data." So Newton could do that same thing in like one sheet of paper with the inverse square law and calculus. So what was very complicated becomes very easy. Of course, it took him like 20 years to invent the calculus. But then after you invent the calculus, all of these problems become very easy, and you can start sending men to the moon. You can, it's not just circles, but you can do parabolas. You can do all these different things, and you can plot traffic and all. There's so many applications. But the basic idea is just that: finding change over time and finding areas under a curve, and that's it. And I actually ordered a new version of this. I actually went back with, so this book is the 4th edition. They actually have it's in the 14th edition. And this guy, Thomas, he's like dead. He's with Jesus now. But they have, I guess, his students came back and updated the revision. So I actually ordered that. We'll see how well they did. But that's it. Very clear, huh?
That's awesome. That's really, I actually did understand some of that because I did watch some other videos on the Math Wizard and stuff. But yeah, I'm not good at math, but I am looking forward to doing I'm looking forward actually to doing the one on game theory maybe next, because that's something that I've listened to. It sounds interesting. But anyway, yeah.
Well, yeah, actually, I brought that up years ago that we should do that, and you kind of go, "Nah, we can't do that." We're going to do like the prisoner's dilemma.
Prisoner's dilemma,
and how that applies to survival, right?
Yeah.
I mean, biologists use it, economists use it, everybody uses it. And what's the best strategy, right? And how does Jesus with turn the other's cheek, how does that actually apply to survival, right?
Right.
And it actually turns out to be pretty good in certain situations.
Yeah.
So yeah, we'll see. So that no, math is actually very, very beautiful. And what's interesting, how much time do we have?
We're almost out of
2
time.
minutes? 1 minute?
Yeah. 2 or 3 minutes.
Okay. So the version we use in these texts is Leibniz's version. We don't use Newton's version because Leibniz was a lot more socially adept. He used like modern symbols, right? Newton did it all through geometry, which was very difficult to understand, right? But he did it first, right? And he didn't even publish it. It was on a shelf in his office, right? And Halley from Halley's Comet, right?
Yeah.
He was talking to Newton in his office, and he was just like flipping through his paper. And Halley, he was an astronomer too. He goes, "Oh my God, Newton, this is friggin' fantastic. You got to publish this. It's been on your desk for like 20 years." And so Halley discovered Newton and finally got him to publish it. But by the time he published it, Leibniz had published his, right? and Leibniz knew Newton. So who knows if Leibniz wasn't also in Newton's office and saw the same thing Haley did and goes, "Oh, talk to you later, Newton." He went back to Germany and wrote his things. But he did use his own. He did use his own symbols. So that's sort of the scandal of calculus. But that was their contribution, not the whole book. The Bernoulli brothers and many other people made a lot of applications.
So you can order this shirt. It's the jerk equation, and it's available on the website. We'll put the link in the description below. Look forward to making some other math videos. And if you have any specific things on math, put them in the comments and we'll see if we can do something on it.
Yeah. And you can put your own picture on there. That's a picture of my dog.
That's a picture of Joseph's dog, but you can put your own picture on there. Yeah. All right. Thank you, everybody, for watching.
Okay.
Do you have anything else? Go ahead.
Yeah, I was just talking to someone I worked with called Catherine, and I was talking about this whole thing, and she was the one who said, "Forget it, I'm too beautiful for calculus, and don't be a jerk about it." And I go, "Oh my God, jerk is an actual equation. We should make a T-shirt." And so she was the one who came, and she is too beautiful for calculus, but she obviously knows it anyways because it's on her T-shirt.
Well, either that or she'll have to learn it now. Bye.
She'll have to learn it.
We hope you enjoyed today's video. We have a lot more mathematics videos coming, including one on arithmetic and game theory. So make sure you're subscribed and sign up for the Goofy Historians Patreon to never miss any content from us. Goodbye.